by the box.
Welcome to another AVU Tech.Know. My name is Brandon, and today I'm going to try and explain one of the more complicated parts of building a component audio system, and that is power matching. That's when you try to determine how much amplification you need to drive a particular set of speakers. Now, usually this number is delivered in watts, but the actual listening experience doesn't tie too closely to how many watts you drive down the line. So what I'm going to try and do is explain the different things that affect the listening characteristics of speakers and why you might want a more or less powerful amplifier. Now, the first thing you need to know is the different kinds of power ratings that you're going to find on your amplifiers and your speakers. Basically, they break down into two categories for the most part. You're going to have RMS power. That's the amount of power that it takes to run the speaker all day long without hurting it, or the amount of amplification power that your amplifier is pushing out that it can run all day long without getting too hot. Now, the other one, and the one that they most often give you, is peak power, because this is a very impressive number. It's usually way up high in the hundreds of watts, but it can only sustain it for who knows how long. There's no real agreement in industry as to exactly how long peak power has to be. So it could be it hits 200 watts and then it catches fire instantly, or maybe it can sustain 200 watts in small bumps over a period of time. It really depends on the manufacturer's own discretion. Same thing on your speaker. Maybe it can hit 250 watts of input on certain notes, but it can't sustain that without overheating. So you don't really want to look at peak power numbers when you're doing this sort of matching. RMS is far more important. The other thing you need to know is ohms, or impedance. It's that funny Greek letter when you're looking at the back of your speaker. Now, the higher the amount of ohms that your speaker is rated for, the harder it is to push electricity through. It's resistance. So if you have a speaker that has 8 ohms, it's harder to push electricity through than a speaker that has 4. Usually that means that a speaker that plays at 4 ohms will play louder than the same speaker at 8. Now, note that I said the same speaker, because different types of speakers with the same ohm rating can actually play at varying levels, and that depends on how efficient the speaker is, which is a category that there is really no number for. So let me try to explain how speakers work so that you can get an idea for how that power is going to be consumed and maybe how much amplification you could guess at. Now, the first thing that's important to note is that I've chosen a bookshelf and a tower with the exact same speaker and the exact same tweeter for the top two here. So tweeter, speaker, same models as the tweeter and speaker in this bookshelf. Now, that means that when you're listening to music, all the high notes are going to draw the same amount of power for this larger tower as for this, because the information that is being pushed into the speakers, the amount of power this is using, say to play parts that are flute or spoken, because voices are higher in the register, fluters higher in the register, it's only firing the tweeter and the mid. Now, this one will have to fire the mid for the lower notes too, which means it uses a little bit less power. Now, obviously, if we come over here and you hit a lower note, say a tuba comes in, this thing is now firing. It's adding to the amount of power that is going to be pulled from your receiver. But if you put these on the same receiver at the same volume level, they're going to play equally loud. This one's just going to draw more power. Your volume knob doesn't control how much power. Your volume knob controls the attenuation. It controls how loud your speakers are playing. So if you have the same basic layout, you can have the same volume, but you're still pulling more power with this guy because all the low notes require this extra driver to be fired, whereas this one doesn't have that extra driver. Make sense? Clear as mud? Usually about this point it is. So basically, bookshelves are slightly more efficient in power usage than towers, but it doesn't mean that you can't drive a tower with the same thing you would drive a bookshelf with. It just means you're going to run out of power sooner. So as you turn this guy up, it's going to bounce off of its surrounds. It's going to be extremely loud, and there just won't be any more to give you before you run out of power. Whereas this guy, as you turn him up, at the equal loudness as this, you might find that you're actually running out of juice. Knobs in the same position, you're getting the same amount of loud, but suddenly there's not enough power to kick these bass drivers because there's not enough to feed it those extra cones down here. It's a little bit tricky to think about, but think of it like a garden hose. If you're running water down a garden hose and somebody pokes a little hole in it, that's your tweeter. A little squirt of water comes out. Now that water's not available to keep going down the hose, so somebody a little bit further down pokes a slightly larger hole, that's your mids. More water comes out. There's only so much left over to come out the end of the hose. Now the more speakers and drivers you put in that garden hose, the more holes you put in that hose, the more power it takes. Eventually, you'll run out of water as you move down the line. This thing has less holes in the hose, therefore it will play louder longer until it runs out. Now there's another trick going on here. Discounting towers that obviously have more drivers and require more power to play lower notes, these two speakers actually play at two different levels on the same system, even though their specs are incredibly comparable. Same impedance, same rough power handling characteristics within a couple of watts. Now, the reason why these two speakers play at different volume levels at the same level on your receiver is because this one is more efficient than this one. This Prestige speaker from Paradigm has a lot of resistance to the movement of the cone. This isn't electrical resistance in the line. It just means that these things are far more rigid and harder to drive out. These are in a much softer surround. They move more easily. Now, they do that on premium speakers because that more difficult to move cone means it will iron out imperfections in your music. If you get a little electrical pop or click or some sort of hum through your amplifier, you won't hear it here because that's not enough power to move the cones. Here you might hear it, but that also means that at the same volume level, this one will play quieter. It means that you need a more powerful amplifier to drive this overall because it takes more power to move these cones at any particular point on the spectrum. So I have a system at home using a speaker more like this one that I can run on a reasonably powerful amplifier. But if I wanted to run the same style of speaker as this in a tower, even though the numbers are pretty much the same, it would play super quietly because it takes so much more energy to move the cones and tweeters on this. So if the numbers really don't tell you anything, except for very generically what will drive what, how do you know that the setup that you've chosen is going to sound good and going to work for your particular application? Well, that's when you got to find an audio shop that you trust. That's when you got to find a sales guy that you like to work with. And I had to do it the same thing. I had to come into the shop, I had to hook together the components that I was interested in purchasing, and I found the system that worked great for my needs. Make sure that you do the same. You should never buy audio equipment untested, especially not components, because there's just not a real feel for how things are going to sound, if they're going to match up right in pure numbers. Now you can get pretty close and you can get lucky, but as far as doing this right, if you're especially building a multi-$1,000 system, you want to make sure that you come down and plug it together and listen to it and that you're satisfied with it. We're happy to do that for you. There's really nothing better than playing with the equipment that we have in our shops. We love to do it. So we hope to see you down here soon. If you're interested in purchasing component pieces, I hope that I've sort of demystified some of how speakers work and how power matching actually works and how it's all a bunch of wizardry anyways, and there's just no way to really know. But you're a step closer anyhow. Cheers, this has been Brandon for Audio Video Unlimited, and we hope you've enjoyed this Tech.Know Tech-torial.
Life is better.